All right, so I'm going to go over this review so that you guys have it in preparation for your first quiz of the second quarter. All right, so we don't have all the details of the quiz. At least at the time that I'm making this, I might have more information for you guys in class. But in this review, everything is separated by category. So it says solve by factoring. On the next page, it's going to say solve by taking the square root, and then it's going to say solve by completing the square. Your quiz, as far as I know, might just say solve. In that case, you would just use any method that you feel comfortable with, as long as it's one of the three that we've gone over in 1.4 A and B. So by factoring, by taking the square root, and by completing the square, any of the three. All right, but I'll just go through the review so you guys have enough practice with the kinds of problems that you're going to see. All right, so solve each equation by factoring. So number 1, b squared minus 10b plus 21 equals 0. The first thing we need is that the entire equation is set equal to 0. Right, that's already done. So now we want to factor. Right, and then this is going to factor. We're looking for factors of 21 that add to negative 10. Right, and it's going to be b minus 7 and b minus 3. And then we set it equal to 0. And then now that it's set equal to 0 and that it's factored, we want to set each factor equal to 0. So b minus 7 equals 0, b minus 3 equals 0. All right, so let's add 7, add 3. So then we get our two solutions, b equals 7 and b equals 3, right? And I keep saying it, in all of these you should get two solutions, right? There are special cases where you might just get one. Right, something like the second one, I'll tell you now. Something like this one is one that's going to have one solution, and I'll show you why. First, you want to make sure that the entire equation is set equal to 0, right? It is. So we're good to proceed. So we're looking for factors of 64 that add to negative 16 is going to be negative 8 and negative 8. All right, this is a perfect square trinomial. So you get a minus 8 times a minus 8 equals 0. And so we have the exact same factors, but we can still set them both equal to 0. And if you get the same solution twice, which we do here, right, if we add 8 on both sides, we get a equals 8. You can just write it once, right? Something like this, we get the exact same solution twice. So we still technically get two solutions. They're just the same solution, right? So we just get one answer. Right, and you're good to just write it once. All right, something like number 3 only has two terms. It's set equal to 0, right? That's done for us, right? So now we want to take out a GCF, right? If you can't factor a trinomial, binomials should be a little bit simpler, right? You don't have very many options. It's either going to be sum or difference of cubes, difference of squares, or just a GCF, right? Or maybe a combination of some of them, right? Here we can take out a 4a. When we take out a 4a, we're left with 11a minus 1 equals 0. And then we want to set each factor equal to 0, right? So 4a equals 0, 11a minus 1 equals 0. Divide both sides by 4. We get a equals 0. All right, on the other one, we want to add 1 on both sides. We get 11a equals 1. All right, divide both sides by 11. We get a equals 1 over 11. All right, same thing with the next one, number 4. All right, we only have two terms here. It's already set equal to 0. Right, so now we just want to check if there is a GCF. This is obviously not a difference of squares or anything like that. So we want to take out a GCF. Here we can take out a 3m, right? Once we take out a 3m, we're left with m plus 14, and this equals 0. All right, now we want to set each factor equal to 0. So we get 3m equals 0, and m plus 14 equals 0. All right, so divide both sides by 3 on this one. We get m equals 0. And then subtract 14 on this one. We get m equals negative 14. All right, good. All right, number 5, we're still factoring, right? First, we want to check, is it set equal to 0? This one is, right? So now, Is there any GCF that we can take out? Right, this one doesn't have one. So now this is one where we have to multiply the first and the last term, right? 4 times 10 is going to get you 40. And we want factors of 40 that add to 13. Right, this one's going to be 8 and 5. Now there's two ways that you can factor this. Right, there's the classic way that we've been doing it, the old way that we just split up the 13p into 8p and 5p. I'll do it the other way, just so that you guys can, get used to seeing it. So we can do p plus 8 and p plus 5. Now, if you leave it like this is wrong, right? But what we can do, we can slide and divide, right? Divide both of our numbers by 4. Whatever simplifies can just stay, right? So 8 and 4 simplify to 2. That can stay on its own as a factor, but 5 and 4 can't simplify. We can slide the 4 up in front of the p. So we get 4p plus 5. And then this equals 0. All right, and this is the same as if you were to split up the 13p into 8p and 5p and then factor by grouping, right? Either way works. All right, and so now we want to set each factor equal to 0. So p plus 2 equals 0. 4p plus 5 equals 0. All right, so then we get p equals negative 2. All right, subtract 2 on both sides. All right, subtract 5 on both sides. We get 4p equals negative 5. Divide both sides by 4. Then we get p equals negative 5 over 4. All right. All right, let's keep going. So this next one, first thing we always want to check is the entire equation set equal to 0, right? And this one isn't. So let's move everything that's on the right to the left, right? So let's get rid of this 12b here, and let's get rid of that 4. All right, so minus 12b plus 4, and this entire side goes away. So we get 5b squared minus 12b plus 4 equals 0. All right, and now can we take out a GCF? We cannot. So we just want to factor by grouping or slide and divide, whichever one. So if you make this x, 5 times 4 is 20. So we want factors of 20 that add to negative 12. And this is going to be negative 10 and negative 2. All right, so I'll do this one the old way, right? I'll show you guys how this is going to work. Once we get our negative 10 and negative 2, split up the negative 12b to be negative 10b minus 2b, right? And then just bring everything else down with it. So 5b squared and then plus 4 equals 0. And now we want to factor by grouping, right? Now that we have 4 terms, we can group. All right, so grouping the first two, grouping the second two. GCF of the first two is going to be a 5b. And then we're left with a b minus 2. And then GCF of the next pair is going to be a negative 2. And then again, we're left with a b minus 2. All right, and then we should get 5b minus 2 times b minus 2 equals 0. All right, and now we want to set each factor equal to 0. So 5b minus 2 equals 0. And then b minus 2 equals 0. And now we just solve for b in both of these equations, right? So solving for b over here, we get plus 2 plus 2. We get 5b equals 2, divide by 5 on both sides. We get b equals, I'll write it up here, b equals 2 over 5 as one of our answers. And then in the other one, so in the second equation, b minus 2 equals 0, we just want to add a 2 on both sides. So then again, we get a b equals 2. And we get our two solutions. All right, let's try the next one. Same thing as the other one. We want to get everything to one side of the equation. I'm going to move, again, everything on the right to the left. I don't like when the squared term is negative, so I'm going to just add it. All right, so plus 5n squared plus 12. Again, plus 5n squared plus 12. And then we get 5n squared minus 32n plus 12 equals 0. And then you're looking for factors of 5 times 12 is going to get you 60. Factors of 60 that add to negative 32. All right, keep in mind negative 32 is a big number, so you want to make sure you have kind of a bigger factor and then a smaller factor, right? So because you want to reach this negative 32. And to do that, it's going to be negative 30 and negative 2. Right, I'm going to kind of go back and forth between the two methods of factoring, right? So I'm going to do the slide and divide one here, right? So I have negative 30 and negative 2. I'm going to do n minus 30, n minus 2, right? And don't forget, divide both of the numbers by 5. And then 30 divided by 5 gets you 6. So n minus 6 is one of our factors. 2 divided by 5 doesn't simplify. So you want to bring the 5 up front. So we get 5n minus 2 equals 0. All right, and then you want to set each of your factors equal to 0. So n minus 6 equals 0. All right, and then 5n minus 2 equals 0. All right, add 6 on both sides. We get n equals 6 as one of our answers. All right, add 2 on both sides. 5n equals 2, and then divide by 5. We get n equals 2 over 5 as another one of our answers. All right, and then I go with the next one. All right, so again, I'm going to add the 3x squared and subtract the 22x. So I'm going to add 3x squared minus 22x, then you get 3x squared minus 22x equals 35. Or no, I'm sorry, plus 35 equals 0. And then, again, there's no GCF that we can pull out, so we're just going to factor it, right? 3 times 35 should get you 105. And then you have factors of 105 that add to negative 22. All right, so this one should be negative 15 and negative 7, right? If you couldn't think of it that quick, right, you can always make a list of some factors, right? You always want to start with the factors first and then see what can add to this number here, what can add to negative 22, right? It should get you negative 15 and negative 7. All right, and then this one, let's do slide and divide again. So I'm going to do x minus 15, x minus 7 equals 0. Right, you might find that this is a little bit quicker, right? And then you want to divide by that 3. And then x minus 15 divided by 3 is 5, so we get x minus 5 as one of our factors. And then 7 over 3 doesn't simplify, so we can slide the 3 up front. So we get 3x minus 7 equals 0. And then again, you want to set each of your factors equal to 0, so we get x minus 5 equals 0. So we get 5 as one of our answers. All right, and then 3x minus 7 equals 0. Add 7 on both sides, we get 3x equals 7. Divide both sides by 3. And then you get x equals 7 over 3 is another one of your answers. All right, and that's it for the factoring section. Let's try some of the square roots now. Right, so to solve by taking the square roots, this one's a little bit different from factoring. We want the squared term by itself. All right, so we want the squared term by itself. Now, before in the factoring section, we wanted the entire equation set equal to 0. This time, look at number 9. Our squared term is a squared. Right now, it's not by itself. We need to divide by that 25 on both sides. All right, so a squared equals 16 over 25. Now that the squared term is by itself, we want to square root both sides. And then the square root cancels with the square, and we get a equals plus or minus the square root of 16 over 25. Right, don't forget the plus or minus. Right, anytime you take the square root of a variable term or expression, it's always a plus or minus. All right, and now you want to simplify the radical. You can't leave your answer like this. So we get a equals plus or minus. You can split up square root of 16 and square root of 25, and these are both perfect squares. So we get a equals plus or minus 4 over 5. All right, and now number 10, similar thing here, right? Our square term is this b squared, right? So we want to divide by that negative 2 in front of it. So you get b squared equals 82 divided by 2 is 41, and they're both negative, so it's going to become a positive 41. And now that the square term is isolated, you want to square root both sides, canceling that square. So then you get b equals plus or minus the square root of 41. And the square root of 41 is not a perfect square, nor does it have any factors that are perfect squares. So you can just leave it alone, and this is your answer. All right. And now looking at number 11, right, same thing here. Our squared term isn't just a b, right? So it's not just a b squared. This time we have an expression squared, right? But again, we want this entire expression isolated. Now this b minus 5 is the only thing that's being squared, right? Not the 4 out front. So we want to divide by that 4 on both sides. So then you get b minus 5 squared equals 3 over 4. And now you want to square root both sides. All right, cancel the square and the square root. We get b minus 5 equals plus or minus the square root of 3 over 4. And then finally, to get the b by itself, we want to add 5 on both sides. So you get b equals 5 plus or minus the square root of 3 over 4. All right, and now you want to simplify the square root. All right, again, you cannot just leave it like this, right? Square root of 3 over 4, right? This is the same as square root of 3 over the square root of 4, but the square root of 4 gets you 2. All right, so that's going to get you 2. And then our final answer is going to be b equals 5 plus or minus the square root of 3 over 2. All right, let's keep going. Number 12 should be a super easy one, right? The squared term is already by itself. The only thing you have to do is square root both sides. So we get k equals plus or minus the square root of 9, but the square root of 9 is 3. All right, so this one's just k equals plus or minus 3. All right, nothing special going on there. All right, and the next one. Again, the squared term is already by itself, right? Our squared term here is this v plus 3, right? This is the thing that's being squared, so we just want to take the square root of both sides, immediately cancel out that square. So we get v equals 3 equals plus or minus the square root of 18, and then you just want to subtract that 3 on both sides. All right, so we get v equals negative 3 plus or minus the square root of 18, and then simplify the square root of 18, right? This can become the square root of 9 and the square root of 2. So we get v equals negative 3 plus or minus 3 square root of 2. All right, and there's your answer. Now you could also write the negative 3 on the other side, right? So you could say v equals plus or minus the square root of 18 minus 3, right? That's not conventional, but it works. The only problem with that is maybe, depending on your writing, maybe that minus 3 is going to creep up under that square root, right? And then you're going to do 18 minus 3 under the square root, and you're going to get plus or minus 15, right? And that doesn't work here, right? So that won't work, but as long as you just write it clearly distinct from this plus or minus 18, then that works, right? And then you have to fully simplify, of course. All right. And then number 14, you want to get the squared term by itself again, right? So k squared minus 2 equals 62. We want to add that 2 on both sides. So then we get k squared equals 62 plus 2 is 64. All right, square root both sides. Cancel the square, we get k equals, square root of 64 is 8, and we need a plus or minus. So we get k equals plus or minus 8. All right. All right, and now we want to complete the square, right? So the rest of these problems are by completing the square. I tried to have a decent amount of these in here because I want you guys to be able to practice, right? This is the one that kind of got some of you in class, right? So let's just keep it going. right? So in the lesson video for this, I showed you guys like a 5-step method, right, to get to solve by completing the square. The first thing is we wanted to get the n squared and the n on one side, right? So we want to move the constants to the other. So we want to add 35 on both sides, right? That's the first thing we want to do. Then we get n squared plus 14n, and then leave a little space, equals 35. Again, same space on the other side. And then what goes in that box is our second step. We want to add b over 2 squared on both sides. In this case, b is 14. 14 over 2 is 7. And when we square 7, we get 49. So we want to add 49 on both sides. And then the third thing we did was we wanted to factor the perfect square trinomial, right? And that perfect square trinomial factors with b over 2. In this case, b over 2 is 7, so we get n plus 7 squared equals 35 plus 49 is going to be 84. All right? And then from here, this is just like solving by taking square roots, right? The next step was we wanted to square root both sides, right? Square root and the square cancel. We get n plus 7 equals plus or minus the square root of 84. And then the last thing we wanted to do was get the n by itself and simplify. So we want to subtract 7 on both sides. We get n equals negative 7 plus or minus the square root of 84. And then to simplify this, right, 84 can be broken down into 4 and 21. And 4 is a perfect square, right? So we get 2 square root of 21, right? Square root of 4 is 2. And then 21 cannot break down any further, right? There are no perfect squares in it, nor is it a perfect square itself. So this is your answer. All right, and it's going to be that process every single time. It gets a little bit different when we have numbers in front of the square term, right? But we'll get to that in a minute. Right, again, the first thing you want to do, get the constants to the other side. So let's add 40, and then we get n squared minus 18n plus a little space equals 40 plus a little space. All right, and then we want to find what goes inside of that little space. It's going to be b over 2 squared. In this case, our b term is negative 18. Right, negative 18 divided by 2 is negative 9. And negative 9 squared is positive 81. All right. And then we want to factor the perfect square trinomial. It's going to factor with our b over 2 term. Our b over 2 term is 9. So we get n minus 9 squared equals 140 plus 81 is going to be 121. All right, and then once it's factored, we want to take the square root of both sides. All right, and then cancel the square root and the square. We get n minus 9 equals plus or minus. We can simplify this right away, right? Square root of 121, you should be able to recognize that that's a perfect square, right? It's 11. All right, and then the last thing we want to do is get the n by itself, right? Plus 9 plus 9. And then we get n equals 9 plus or minus 11. Now you don't want to leave this alone like this because these are both whole numbers, right? So you're able to actually get two solutions, right? Plus or minus means exactly that. One is plus, one is minus. So we're going to have 9 plus 11 and 9 minus 11. So we should get 20 and negative 2 as our answers. Right, this one you should write out your two solutions, right? 20 and negative 2. All right, and actually, as a matter of fact, in this case, we got our two whole number answers. This typically means that our original equation we could have factored, right? So factors of negative 40 that add to negative 18 are negative 20 and positive 2, right? And then we factor that and solve, we get our exact same answers, right? Now, like I said, I don't know the details of how the quiz is going to be set up. If it says to solve, then solve using any method you want as long as it's from these three sections. Or no, from these two sections, right? Factoring, taking square roots, completing the square. But if it specifically says solve by completing the square, then you have to do it this way or you won't receive full credit. All right, let's keep going. Number 17 is the same process, right? Like I said, it's going to be the same process every time. We want our squared term and the n by itself. Constants on the other, so let's add 5 on both sides. And then add a little space. All right, equals 5 plus a little space. And then what goes inside of that little space is b over 2 squared, right? In this case, our b term is 2. 2 divided by 2 is 1. And then 1 squared is 1, so we're just adding 1 on both sides. And then we want to factor the perfect square trinomial. It's going to use our b over 2 term, right? So it becomes n plus 1 squared equals 5 plus 1 is 6. Now we just want to take the square root of both sides. We get n plus 1 equals plus or minus the square root of 6. And now the last thing we want to do is just get the n by itself, right? Let's subtract the 1. So we get n equals negative 1 plus or minus the square root of 6. All right. So we get our two solutions here, and 6 is not a perfect square, nor does it have factors that are perfect squares, so you just leave it alone. Your answer is going to look like this. All right, last page, and this is all by completing the square, right? So let's keep it going. First thing you want to do, again, get all your constants to one side. So let's add 73 on both sides. So we should get x squared minus 6x. Add the little space as always, right? Negative 7 plus 73 should get you 66. Whoa, hold on. Yeah, 66. And then plus the little box. All right. And then the next thing we wanted to do is add b over 2 squared, right? Our b term is always the term in front of the x. It's going to be this negative 6, right? So negative 6 divided by 2 is negative 3. And then negative 3 squared is 9. So we're adding 9 to both sides. All right. And then factoring the perfect square trinomial, it's going to be x plus whatever b over 2 was. So negative 3. So x minus 3 squared. And then 66 plus 9 should get you 75. And then you want to square root both sides. Right, now that the squared term is by itself, we get x minus 3 equals plus or minus the square root of 75. And then the last thing you want to do, get the x by itself and simplify your answer. Right, so we get x equals 3 plus or minus the square root of 75. But the square root of 75 you can break up into 25 and 3. Right? If you couldn't recognize that, you could just keep breaking it down until you get an answer that's going to simplify exactly the same way. Right? So we get x equals 3 plus or minus square root of 25 is 5 times the square root of 3. All right. And now the next one. Again, we want to get everything on one side, right? This one's a little bit different, but first let's get our constants on the other side. So plus 48 on both sides, then we get 8k squared plus 16k, right? And our little space, as always, right, equals 4 plus 48 is 52, again, plus our little space. But we can't really proceed until we get the k squared to not have that 8 in front, right? We can only solve these problems by completing the square when you don't have a coefficient in front of your squared term. All right, so let's divide everything by 8, right, just to get rid of that k squared. And you could have done this from the beginning, but the only reason I didn't do that is because you would have gotten a fraction with the 4 over the 8, and then you would have to combine the constant with the fraction. If you don't like fractions, you should do it this way, right? You'll avoid it, right? You'll still see a fraction, but not as many as it would have been, right? You wouldn't have to find the common denominator or anything, right? We get k squared plus 2k plus, we still have a little space, and then 52 divided by 8, they share a factor of 4, so we can divide the top and the bottom by 4. We get 13 over 2, and then plus a little space. All right, and now we can factor it just as we've done before, right? Find our b over 2 squared term, right? In this case, b is positive 2, so 2 divided by 2 is 1. And then 1 squared is 1, so we're going to add 1 to both sides. And then factor our perfect square trinomial. We should get k plus 1 squared equals 13 over 2 plus 1 is going to be 1 over 1. And then we want to multiply the top and the bottom by 2 to get a common denominator. And then we get 13 plus 2 over 2 is going to be 15 over 2. All right, now we want to get the square root, or now we want to take the square root to cancel out the square, and then we get k plus 1 equals plus or minus the square root of 15 over 2. All right, last thing we want to do is get the k by itself and then simplify our answer. All right, so minus 1, we get k equals negative 1 plus or minus the square root of 15 over the square root of 2. I'm going to go ahead and simplify that. Right, don't forget, guys, if you're dividing under a radical, you can split up the radical into 2 parts, right? So radical 15, radical 2. And then we can't leave our answer like this. We want to cancel out the denominator on the bottom, right? Hopefully we remember how to do this, right? This is called rationalizing the denominator, right? And so you want to multiply by that denominator on the top and the bottom, right? You guys cannot forget how to do this. So we get k equals negative 1 plus or minus, and then this radical 2 and radical 2 on the bottom become just a 2, right? If you see the same thing twice, the radical goes away. And then 15 times 2 is 30, and they're both under a radical. Again, just like I mentioned, if you're dividing under a radical, you can do the exact same thing with multiplication. If you're multiplying 2 things and they're both under a radical, you can write it under 1 radical, right? So this should be your answer. All right, and so continuing with number 20, right, again, same thing. Get your constants to one side, your variables on the other, right? So let's add 74, and then we get 2a squared plus 4a plus our little box equals 74 plus 7 is going to get you 81. All right, and then you want to get the 2 out of that a squared. Right, so you want to divide everything by 2, right? To solve by completing the square, you do not want coefficients on your squared term, right? So doing this is going to get us a squared plus 2a, and then again, plus that blank space is going to equal 81 over 2. Forgot to do the blank space over here, so plus our little blank space. And now you want to add b over 2 squared. So in this case, b is 2. 2 divided by 2 is 1. This is just like the last one, so we're going to add 1 to both sides because 1 squared is 1. And then we get a plus 1 squared equals 82 over 2 plus 1 is going to get us 1 times 2 over 2. Right, we want the same denominator. 1 is the same as 1 over 1. And then multiply the top and the bottom by 2. We should get 83 divided by 2. And then we can take the square root of both sides. All right, and so we should get a plus 1 equals plus or minus the square root of 83 over 2. All right, and then you want to solve for a, get your answer simplified, right? So subtract 1 on both sides. We should get a equals negative 1 plus or minus. And then again, just like the last one, I'm going to split up that 83 and that 2. If you're dividing under a radical, you can split it up. And then you don't want to leave your answer like this. You want to simplify the radical, right? You don't want to leave a radical in the denominator, so we rationalize it. All right, so multiply the top and the bottom by the square root of 2. We get a equals negative 1 plus or minus. On the bottom, square root of 2 and square root of 2 just make a 2. And on the top, 83 times 2 is going to get you 166. And then we leave that under the radical. All right, so this is our final answer. All right, there's just 2 more, guys. So let's try 21. Again, we want to get the constants on one side. So let's add the 1, add the 1. And then we should get 2x squared plus 9x plus our little space is going to equal 5. Again, plus our little space. All right, let me split that up. Okay, and again, just like the other ones, we don't want that 2 in front of the x squared, so let's divide everything by 2. So we get x squared plus 9 over 2x plus our little box is going to equal 5 over 2 plus our little box. And then in this case, we want to, again, find our b over 2 squared term. If our if our b term is already a fraction, right, dividing by 2 is the exact same thing as multiplying by a half, right? So I hope you all agree with that, right? Dividing by 2 is the same as multiplying by a half, and when we're multiplying fractions, you can just go straight across. So we get 9 over 4. So 9 over 4 is our b over 2 term, and now to square it, right, if we remember how to square fractions, right, you can either square the top, square the bottom, and then get, 81 over 16. Or again, you can just write it twice, right, so 9 over 4 times 9 over 4, and then multiplying fractions again, you just go straight across. You get the exact same thing. All right, so we should get 81 over 16 in this little box. All right, and then factoring our perfect square trinomial, we're going to use our b over 2 term. So we get x plus 9 over 4, that was our b over 2 term, squared, and then we want to get a common denominator. All right, so 5 over 2 and 81 over 16, they share a denominator of 16. So let's multiply the top and the bottom of 5 over 2 by 8, right, because we want a denominator of 16. And then we get 40 over 16 plus 81 over 16. All right, and then I'm going to go ahead and rewrite this. It's going to be x plus 9 over 4 squared, and then 40 plus 81 is going to get you 121 over 16. All right, and now you want to square root both sides. Square root. So we should get x plus 9 over 4 equals plus or minus the square root of 121 over 16. Now, hopefully you recognize that these are perfect squares. Now, when we go to get our final answer, so minus 9 over 4 on both sides, right, we should get x equals negative 9 over 4 plus or minus square root of 121 is going to be 11, and square root of 16 is going to be 4. So plus or minus 11 over 4. All right, so we get this. We get rational numbers which can be simplified. So we actually want to split up our answer into 2 parts. So we get negative 9 over 4 plus 11 over 4, and then we get negative 9 over 4 minus 11 over 4. Right, remember this plus or minus means exactly that. One is plus, one is minus. So negative 9 over 4 plus 11 over 4 is going to be 2 over 4, which is 1/2. And then negative 9 over 4 minus 11 over 4 is going to be negative 20 over 4, which is going to be negative 5. So we get our 2 answers like this. Again, if you get nice answers like these, it probably means your original expression or equation could have been factored, right? And that's how you could have solved it. But again, if the question is asking to solve by completing the square, you have to take this route, right? But your instinct should always be to check, can it be factored? All right, and now let's do the last one together. We want to get our variables on one side, move the constants to the other. This is a nice case where we don't have a number in front of the x squared. So we just get x squared minus 11x plus a little box is going to equal 7 plus a little box. All right, but we do get a fraction here, right? Because when we divide our b term by 2, we get negative 11 divided by 2. And then when we square that, we're going to get 121 over 4. All right, 121 over 4. All right, and then to factor the perfect square trinomial, this is going to become x minus 11 over 2, right? We use our b over 2 term. Squared equals, and then we want to get a common denominator, right? 7 is the same as 7 over 1 multiply the top and the bottom by 4, so we should get 28 over 4 plus 121 over 4. All right, and then that's just going to get you, right, 28 plus 121 is going to get you 149. All right, so let me go ahead and erase this. I'm going to make it 149 over 4. All right, and then you want to square root both sides. And then we get x minus 11 over 2 equals plus or minus square root of 149 over 4. All right, and then you want to add 11 over 2 on both sides. And then we should get x equals 11 over 2 plus or minus the square root of 149 over 4. All right, so we get x equals 11 over 2 plus or minus, and then 149 and 4, you can split those up, so we get square root of 149 over the square root of 4, but the square root of 4 is just 2. All right, so this is our final answer. All right, now you could also, since they have the same denominator, you could also write it as one single fraction, so square root of 149 all over 2. Right, that works as well. Both of these are equally correct. Right, so no matter which one you write, as long as they have the same denominator, you can write it under the same fraction, right? Either way, it doesn't matter, right? Either way is fine. All right, and that's your review. Hope this helps.